Hi everyone. Today I will present my project titled H&M Fashion Recommendation System. It is an end-to-end machine learning project built using the official H&M Personalized Fashion Recommendations dataset from Kaggle. The project demonstrates the complete data science life cycle from data pre-processing and exploratory data analysis to recommendation model development and deployment using Streamlit. I am Devdeep Chowdhury and I am a professional data scientist based in London. My interest spans across providing data science solutions and machine learning solutions to real world companies. Online retailers sell thousands of products like H&M. They sell more than 1 million products, making it difficult for customers to discover relevant items. Recommendation systems solve this problem by suggesting products that are likely to match a customer's interests. The goal of this project is to improve customer experience while increasing sales and customer retention. So we follow an end-to-end data science project workflow, starting from data collection to data quality checking, like handling missing values, uh, then dropping null rows, then doing exploratory data analysis, and then doing feature engineering. Then we do RFM segmentations, which stands for recency, frequency, and monetary segmentations, and then building recommendations, and then finally evaluating our recommenders model, and after evaluation, we deploy it uh, to a cloud-based platform like Streamlit in this example for in order for our final web application. The project uses the official H&M Personalized Fashion Recommendations dataset. The dataset consists of three primary tables. First is articles, second is customers, third is transactions. Together, they contain more than 31 million purchase records, making this a real-world large-scale recommendation problem. The article dataset contains approximately 105,000 products. The customer dataset contains over 1.37 million um, customers. The transactions datasets contains around 31.8 million purchases. These datasets are linked using customer IDs and article IDs. Before building any model, data quality was assessed. Most missing values were occur in optional customer information such as fashion news preferences and activity status. Product descriptions had very few missing values, indicating good product metadata quality. Duplicate records were also investigated. The articles and customers datasets contained no duplicate rows. Duplicate transaction records were analyzed carefully because repeated purchases may represent legitimate buying behavior rather than data errors. Then memory optimization was done. Due to the dataset size, memory optimization was essential. Appropriate numeric data types were used to reduce memory consumption. This significantly improved computational efficiency during pre-processing and recommendation model development. Then we try to do entity relationship and basically creating the data model using the various relationships. We connect customers to transactions using customer ID and then using the customer ID and article ID found in the transactions table. We connect it with the articles. In this way, we try to find relationships between the different tables in order to build our final data model. As I said earlier, significant memory optimization was done because large data sets require efficient processing before modeling. Data type optimization significantly reduces memory usage. So we did a lot of memory optimization because transactions remain the main computational bottleneck due to 31.8 million records alone in the transactions dataset. Efficient memory use is essential for feature engineering, RFM analysis, and recommender training. Then we perform exploratory data analysis to gain insights on our dataset. So here we find the top product types, uh, products such as jerseys, accessories, knitwear, and trousers dominate the catalog. These catalogs contribute heavily to customer purchases. Garment upper body products dominate the catalog. Accessories and lower body garments from large secondary groups. This helps understand product assortment strategy. Black is the dominant color group by a larger margin. White, dark blue, and light pink are also major catalog colors. Color similarity is valuable for fashion recommendations. Then we do garment group analysis. The visualization highlights the different garment groups. Jersey fancy products represent the largest product category, followed by accessories and jersey basic. This information is valuable when developing a popularity-based recommendation systems. Products are distributed across multiple retail departments. Understanding department composition helps retailers identify dominant product categories and inventory allocation. Women-focused departments contributed large product volumes in our dataset. Department catalog allocation is also uneven across uh, dif- uh, departments. Product sections reveal customer target segments and business divisions. Large sections suggest strong merchandising uh, focus. Sections metadata can improve product similarity and uh, filtering. So as we can see, the women's everyday collections had a larger bar chart combined with baby essentials and then divided collections and then kids collection. So this gives us the most strongest sections among the whole dataset. This chart shows the distribution of customer ages. Most customers belong to the young adult and middle-aged groups. Understanding age distribution helps retailers design age-specific recommendation strategies. The 21 to 30 age group is the largest segment. Age groups provide more actionable market segments than raw ages. Younger adults represent the strongest visible customer base. Most customers are active members. Loyalty status can be useful for targeted retention campaigns. Unknown or inactivated statuses should be handled carefully in modeling. Most customers have no fashion news subscription. Regular subscribers represent a valuable engaged audience. Marketing preferences can guide personalized campaign strategy. Then we have the monthly sales trend figure. This figure illustrates purchasing behavior over time. Seasonal fluctuations can clearly be observed. These trends can later be incorporated into time-aware recommendation systems. H&M sells products through two channels. So sales channel analysis is very important. The majority of purchases occur through the online sales channel. This indicates increasing customer preference for online shopping. So the channel 2 is the online shopping. So the next figure is the transaction price distribution. Most transaction prices are low normalized values. The distribution is right skewed with a long tail of higher priced items. Price sensitivity is important for product ranking. Here we identify the individual products generating the largest number of purchases. These products are excellent candidates for cold start recommendations. For instance, Jade HW Skinny Denim TRS jeans is the top purchased item. Best sellers are strong candidates for popularity based recommendations like these ones over here. Popularity product level demand supports inventory and merchandising decisions. Trousers lead purchase volume by a large margin in the top 20 best-selling categories. As we can see, trousers is a very large value over here. Trousers and sweaters are also the second and third highest demand categories. Category level like this gives us very important insights about actionable and important insights than single product counts. So here we can see the top 20 most active customers. A small number of customers purchase extremely frequently. High frequency buyers can be targeted with VIP or loyalty strategies. The active customers provide strong behavioral signs like for recommendations, like we can target these uh, active customers, top 20, top 50, top 100, or top 1000 active customers, and reach out or advertise to them. Purchase frequency varies considerably across customers. A small proportion of customers purchase very frequently, while most customers purchase relatively few items. This long tail behavior is common in retail datasets. Most customers make relatively few purchases. The long tail indicates a small group of highly active customers like these ones in the right side of it. Sparse behavior makes recommendation evaluation challenging. Customers were segmented using the RFM framework, which stands for recency, frequency, and monetary value. This enables businesses to identify high value customers and design personalized marketing campaigns. RFM converts millions of transactions into customer level metrics. Recency, frequency, and monetary values summarize the behavior. These features support segmentation and life cycle marketing. So this chart gives us the customer recency distribution. Many customers made recent purchases, but recency has a long tail. Lower recency means stronger current engagement. Recency is often one of the strongest predictors of future purchases. Customer segment distribution. Champions and lost customers are the largest segments. At risk and needs attention groups require re-engagement strategies. RFM segmentations like this helps us translate raw behavior into business actions. Monthly revenue trend. Revenue fluctuates seasonally across months like this. Revenue trends gives a strong business view than transaction counts alone, useful for forecasting inventory and campaign planning. Trousers generate the highest normalized uh, revenue. Dressers and suiters also make major revenue contributions. Revenue AR ranking can balance popularity and commercial value. So like the ZHW skinny denim jeans is the most highest revenue leading product among all other products. The first recommendation model simply recommends the most frequently purchased products. The advantages are very fast, easy to implement, and the limitation of this kind of recommendation is it ignores individual customer preferences. So this kind of recommender that we built here actually recommends globally popular products. It is fast, interpretable, and useful for cold start users. However, it is not personalized. So advanced models are needed for user-specific recommendations. So let us understand the recommendation engine. From simple baselines to personalized hybrid recommendations. So these are the four recommendation engines that we built. First is the popularity based recommendation engine. Second is the content based. Third is the collaborative filtering. And then is the hybrid. The hybrid is like combining all others, multiple signals. It improves coverage. The collaborative filtering is about learning purchasing patterns. Content based helps us use product metadata, and cooperative based is like friendly for cold start and for recommending global popular items to product to customers. In content-based recommendation, the model uses product metadata, including product name, product type, color, department, description, to calculate the factors and cosine similarity, which are then used to identify similar products. Then we also perform Then we also perform collaborative filtering. So collaborative filtering uses historical customer purchases. A user item interaction matrix is constructed. Truncated SVD is applied to learn latent customer preferences. In hybrid recommendation, multiple recommendation approaches are combined. Hybrid systems generally outperform individual recommendation models because they capture both product similarity and customer behavior. Then we come to evaluating our models. So as you can see, popularity-based models gives us simple measurable baselines. SVT results are affected by sparse data and a sampled candidate uh, space. The evolution confirms the importance of hybrid and production-grade recommended frameworks. For deployment, the app emphasizes fast popularity and content-based recommendations only. Then we give the demo of our web application, which we deploy using Streamlit. So this is our Streamlit home dashboard. This is the home dashboard. It provides project summary and KPI, key performance index metrics, introduces the app and recommendation workflow. It acts as the main landing page for viewers and recruiters. Then we come to the dataset overview. So it displays sample records from articles, customers, and transactions, helps users verify data loading and schema. Useful for this is very useful this page for demonstrating transparency in the data pipeline. A popular products page. It shows the most frequently purchased products. It serves as the gold start recommendation baseline. It includes an interactive slider to control result size. So they can select 20 products, 10 products, 15 products, 30, 40, or up to 100 products. Then we have the similar product recommendation. Here, users select a product and receive similar recommendations based on that product they selected. For instance, here, if they select a denim jeans, they are going to receive similar products uh, about other similar jeans items. Okay. So this is built from content-based similarity using product metadata. Example, denim products recommend other trouser or denim items. So this is customer-based recommendation where we select a specific customer using a specific customer ID and then generating the recommendation output based on their customer's history. This demonstrates a personalized app flow. Then this is our customer segmentation. Here it displays customer level recency, frequency, and monetary values, visualizes customer segment distribution, connects analytics with the CRM and retention strategy. So here it's the about the project. So it's basically a concluding page summarizing the project workflow, uh, and then giving a clean project description for viewers and stakeholders. So right now I would like to give a live demo of our web application that we have deployed using the uh, Streamlit web application. I hope you can see the I hope you can see the PowerPoint presentation. Yeah, I hope you can see the screen. So this is the screen of our item. So this is our web application. This is our H&M fashion recommendation system. It's an end-to-end fashion recommendation app using Python, machine learning, and Streamlit. So here we see this is the number of articles, the number of customers, and the number of transactions. So this app is all about building a fashion recommendation system. So this is the dataset overview. This is our articles dataset. It contains article ID, product code, product name, product type name, product group name, and then other features. So this is the slider here. So this contains the color, the perceived color, department name, number, and index code, and other are information about this specific article. Then it is the customer status set. It contains customer ID, their FN, then their active, their club member status, fashion news, their age, their postal code, etc. Then this is the transaction status set. It contains the date of the transaction, the customer ID, the ID of the customers, the article ID, the item the customer brought, then the price, the amount of money they paid, then it's the sales channel ID, how they brought it. So two means probably online, they brought it through online. So one means offline and two means online. Then we just see the popular products recommendation. This part is going to oh, give us the popular products recommendation. It will take some time, but yeah. So it's the popular products. So for instance, we want to select the number of popular products. Here we select 20, and it's the top 20 most popular items based on their global value. First is this, then this. So first item was the denim trousers, jade red skinny denim trousers. Then came the socks items, trousers, then the socks, then the t-shirts. So in this way, the top 20 items that are sold over here. And if we can change it based on this. So here if we see top 18, we are going to see top 18 items. So here we can see the most popular products. So it's going to show us top 18 most popular items based on this. Then we can go to similar products. So here it is going to give us a list of similar products based on a specific products that is going to be chosen. So So let's go back to our PowerPoint presentation. So as you can see, the screenshots are also given over here as well. So it's a customer based recommendation. So based on a chosen customer, it's going to give us the recent customer purchases. Then we have the item based recommendation system, similar product recommendation based on a chosen product. We're going to recommend the app can recommend similar products, and and then yeah, these are some of the features that we have in our items. So what is the business impact of this entire system? Yeah, the system to retail decision making for H&M company. So here we deliver personalized customer experience and personalized item discovery. This reduces friction and improves product relevance, uh, improving customer experience and satisfaction. Then RFM segments support targeted retention, loyalty, and win-back campaigns, improving retention. And also popularity and revenue insights inform stock planning and promotional strategy, improving merchandising. Modular recommender design supports future hybrid and deep learning extensions. This improves scalability of the system. So what could be the future improvement? In the future, we try to integrate product in page image embeddings using CNN or clip style models. We shall use light FM or implicit ALS for stronger collaborative filtering on sparse retail data. Would also add expandable recommendations such as color match, garment similarity, category match, and popularity signal. So basically, we are going to add explanations such as why the model is recommending certain items. Why is the reason? It could be the color, it could be the garments similarity, it could be the category match, or it could be the popularity based signal. Then we will deploy pre-computed module artifacts and lightweight app-ready data samples. So basically here we shall improve the data samples, and we will also add live dashboard metrics and A/B by testing hooks for business experimentation. So thank you for watching this video. If you find this useful, please like it and subscribe to our channel. Thanks.